All right, good morning. And today for our asynchronous Monday, here's what we're going to be working on. We're going to do page 395 in your packet, which I have right here, page 395. I'm going to modify the instructions a little bit, and then we're going to do one word problem. We're going to do a word problem from your textbook, okay? And then the homework is what's written on your assignment sheet for today. Okay, for each of the equations below, you're going to transform it so that theta or x is in terms of y. Then you're going to, well, actually this part we're going to skip. Okay, so all you're doing is you're transforming so that theta or x is in terms of y. Okay, so the theta is buried inside this equation. We need to get the theta by itself. Okay, here, get the theta by itself. In number 4, you've got an x. Your angle is that value x is it's an angle measure, but that's going to be an x value rather than a theta value. Okay, but we're skipping the second part. And in your homework tonight, when you do these problems, you're also skipping the second part. You do not have to do the part that says find the first 3 positive values. Focus that. For which theta or x equals a specific value. Okay, so we need to get the theta by itself. So the theta, a lot of things are happening to theta. 10 degrees is being added, then you're taking the cosine of that, then you're multiplying by 4, then you're adding 2. So we have to uncover, kind of like unpeeling from the outside. So we're going to subtract 2 from both sides. Y minus 2 equals 4 cosine of theta plus 10 degrees. Next thing we can get rid of, divide both sides by 4. Okay, so those cancel. Now you've got y minus 2 over 4 is equal to cosine of theta plus 10 degrees. Okay, now we need to get the theta out from inside of the cosine. So the only way to do that is to turn this cosine function into a cosine inverse function. When we turn cosine of this angle into an inverse cosine, this input and this entire output swap places. Okay, so this becomes cosine. Actually, let's write it this way. This goes over here, so now you've got the theta plus 10 degrees equals cosine inverse of the entire thing, y minus 2 over 4. Okay. Now, that quick step made it really easy to get the theta by itself. Now we're going to subtract 10 from both sides. Theta equals negative 10 degrees plus cosine inverse of y minus 2 over 4. That's all you have to do. Okay. There is a second part, find the first 3 positive values, but we're skipping that. Okay. We'll do one more. We'll do a couple more. Okay. This one, you want to get the theta by itself. So the first thing, we peel away from the outside this 4. We can subtract 4 from both sides. Y minus 4 equals 2 cosine of, and I'm going to put an extra set of parentheses around all this because we're actually taking the cosine of the entire thing. 1/2 theta minus 360. Divide both sides by 2. That goes away. So y minus 4 over 2 is equal to cosine of 1/2 theta minus 360. Okay, now we've got cosine of our angle equals the ratio. So now we're going to turn this, swap places with these two things. So we've got the 1/2 theta minus 360 degrees is now equal to cosine inverse of y minus 4 over 2. We turn cosine into cosine inverse, and when we do that, the input and the output have to swap places. The entire input has to go over here, and this entire output is now the argument in your cosine inverse function. Okay? So now we're almost there. We have to get the theta by itself, so multiply both sides by 2. Theta minus 360 degrees equals 2 cosine inverse of y minus 4 over 2. And then add 360 to both sides. Okay. There's your answer for that one. Number 3, I'll leave you to do on your own. I will post the solutions with that one done so you can check your answers. But let's do this one. This one's in radians. You can see that that's a pi over 4 rather than a 20 degrees. And you also see the x. The x usually means working in radians. Theta means degrees. So again, I'm going to do this. Okay. You don't have to use your calculator because we're not doing the second part. Okay. We're just going to get the x by itself. So I'm going to subtract 1 from both sides. Y minus 1 equals 5 cosine of pi over 4 times x minus 0.8. Divide both sides by 5. Y minus 1 over 5 is equal to, 5's cancel, cosine of pi over 4 times x minus 0.8. Now we've got cosine of our angle equals our ratio. We're going to turn it to cosine inverse, and the input and the output switch places. So this thing comes over here, pi over 4 times x minus 0.8 equals cosine. Cosine turns into cosine inverse, or arc cosine. You could write it either way. Y minus 1 over 5. Okay. Now I'm going to multiply both sides by 4 over pi. So this will go away. We'll get x minus 0.8 equals 4 over pi times cosine inverse of y minus 1 over 5. Okay. So, and then we just add the 0.8 to both sides. X equals 0.8 plus 4 over pi cosine inverse of y minus 1 over 5. Okay. And you've got the x value by itself. Okay. Next, I want to go to your textbook. So take a look at your textbook. We're going to do, on page 786, we're going to do the example in 1311. Okay. So this is a word problem. We did some word problems in class the other day. So this is the same thing. There's just one additional step. Okay. So a water wheel is 14 feet in diameter, is rotating as shown in the figure on the next page. I'll show you that in a second. You start a stopwatch and observe the motion of the point on the rim of the wheel. When the stopwatch reads 2 seconds, P is at a maximum distance from the surface of the water. When the stopwatch reads 7 seconds, P is at a maximum depth below the water, or a minimum distance, if we're recording that distance as a total distance from the surface of the water. Okay. So what I would do if I were doing this problem, I would take out if this were on a worksheet, I'd take out my highlighter, highlight or take note of the most important things. 14 feet in diameter, that's important. Okay. When the stopwatch reads 2 seconds, P is at a maximum distance. Stopwatch reads 7 seconds, P is at a maximum depth. So let's take a look at the next page, what this looks like. Okay, so here's the picture on the next page. Okay, here's the depth of the water right here. Okay, the diameter of this water wheel is 14 feet. So the radius is 7 feet. That right there says 7 feet, 7 with a little foot notation. Okay, and the minimum distance was going to be 1 foot below the surface of the water. So if that's 1 foot below the surface of the water and you're measuring the radius straight down, this would be 1, which means this distance has to be 6, because this radius from here to the bottom of the water wheel has to be 7. That's a radius of your water wheel. Okay, so they told us this was 1 foot below. So this is going to be a negative distance. We're going to call this distance -1. And then this distance up here, we're actually going to call it 13. Okay, because the diameter of your water wheel is 14. But we want to know how far is this point from the surface of the water. Okay, so this would have to be 13 plus 1 to give you 14 for the diameter. Okay, and your questions, find the particular equation expressing your distance of P from the surface as a function of the stopwatch reading. And then B, find the time in which P first emerges from the water. Okay, so think about this point P. It's traveling. Okay, as it moves up here, your distance from the surface of the water is increasing. And now as it's going down, your distance from the surface of the water is decreasing. This right here, from your point to the surface of water, that's going to be our D value. Okay? When we get down here, our D value is still the distance from the surface of the water, but it's going to be a negative value. So here we'd have a -1 value, and then back up. Okay. Now, I've written down the key information onto this sheet of paper. Okay, again, this is 1311. It's the example on page 786. The water wheel is 14 inches in diameter. That was important. At t = 2, your P is at a maximum distance from the surface of the water. At t = 7, P, your point, is at a maximum depth below the water, or your minimum distance. Okay. Here's the picture. I rewrote the picture right here. Your diameter distance from here to here is 14 feet, which means the radius is 7. They told us a maximum depth below the water. I think they told us that one 1 foot below, right? Maybe we don't know that, but we know that from the picture. Okay, from the picture they tell us this distance is 6 feet. I don't think they told us that in words, so we didn't really know that till now, but it means it has to be 1 more foot to make the radius of your circle. Okay. Now what I'm going to do is I'm going to basically draw my axis here. We want to measure D as the distance from the surface of the water. So this is my x-axis. Okay. I'm going to draw my y-axis. And they tell us at t = 2, so at 1, 2, at t = 2, P is at a maximum distance from the surface of the water, and we can see from our diagram that's going to be a distance of 13 feet above the water. So I'll call this 13 feet. Then they said at t = 7, P has a maximum depth below the water, so 2, 3, 4, 5, 6, 7. And we're going to be at a -1 because we're down here. So that point's going to be here. Okay, which means it takes 5 seconds to get from the top down to the bottom, which means it's going to take 5 more seconds to get back to the top. So if we go 7 seconds, 1, 2, 3, 4, 5, we're now at 12 seconds reading on the stopwatch. And at 12 seconds, we're back to 13 feet above. Okay, so now our wave axis, this should be the center of the water wheel, which is right here at 6, which makes sense. The distance from 6 to 13 is 7. The distance from 6 to -1 is 7. That has to be right in the middle. Or you can add these up and divide by 2. 13 plus a -1 is 12. Divide by 2, you get 6. So you've got your top dotted line up here, your bottom dotted line down here. You've got your point here, here, and here. At the quarter mark, so halfway between 2 and 7, 2 plus 7 is 9. 9 divided by 2 is 4.5. So right here we got 4.5 seconds, and we should be at the middle line. Halfway between 7 and 12, add them up, is 19. Half of 19 is going to be 9.5. And we'd be at the middle line. So here's what our graph looks like. Okay, this looks like a positive cosine graph if you want to start here and end here. Once you have this drawn, it's fairly easy to draw. I rewrote the equations right here on this sheet, and I'll post this sheet. Find the particular equation expressing the distance of P from the surface of the water as a function of time. So I'm going to just define x as the time in seconds on your stopwatch. I'm going to define y as your distance of P from surface of the water. Okay, so our equation, which we know is y equals c plus a. If we do a cosine, that's going to be cosine b times x minus d. Okay. If you want, you can write out these 4 things: the amplitude, the period, the vertical shift, and the phase shift. Your amplitude is this distance from the middle to the top or middle to the bottom, which was 7, or it's the radius of the wheel. The period The distance for one full cycle started at 2 and ended at 12. So your period is 10, which means your B value we know is 2 pi over the period, 2 pi over 10, or pi over 5. Right. The vertical shift, that's where your wave axis is. So 6, up 6. Your phase shift or horizontal shift, we started 2 to the right, so that's going to be right 2. Okay, so our equation is y equals c, your vertical shift, so 6 plus a, your amplitude 7. That's going to be positive because it's a positive cosine graph. Cosine of your b value, pi over 5, times x minus your horizontal shift, x minus 2. Okay, so y equals 6 plus 7 cosine, pi over 5, parentheses x minus 2. Okay, now find the time at which P first emerges from the water. And we're strictly going to do this on the calculator. Okay, so I'm going to show you on the calculator. I'm going to type this equation into your calculator. Let's go to here. Okay, and we're going to add a graph. So you could go to your home page, just add a new page, add a graphing page. And we're going to type in our equation, 6 plus 7 times cosine of, cosine, and then I'm going to do a control divide, pi over 5, times parenthesis, x minus 2. Enter. Okay. Let's see what we have here. And we've got to do a couple things here. Okay. Looks like using that pi over 5, we calculated the b value using radians. So I've got to go up here and make sure I'm in radians. Okay, that's better. Now let's also go and fix our window to make sense. Our period was 10. We could tell from our picture we probably want x to go from 0 to a little bit more than 10. Our cycle ended at 12. So I'm going to go to your menu. And I'm going to do your window. Your x values went from, we don't need to go all the way back there. Let's just go, say, -2 to 15, a little more than 12. And our y values went up to 13. So let's just do, I don't know, -2 up to 15. And hit enter. Okay. There we can see our graph a little bit better. And this right here is the surface of the water at the x-axis. Okay. Now we could just double check that we have this correct. You could do a menu 5-1 to do a trace, menu 5 for trace, 1, and type in a value of 2. We know at 2 we should be at the maximum, which is 13, and you can see that down here. Your ordered pair 2, 13. And then they told us at 7, so hit 7 and hit enter. 7, -1 makes sense. And our other point was 12, and we were back at the top, so that looks like we did this right. Okay, now find the time at which your point first emerges from the water. So here's where you have to think about, okay, let me see. I'm going to move this equation. Oh, I got to get out of trace mode. Hit escape to get out of trace mode. I'm going to move this thing out of the way. Okay. Now think about what's happening here. Here your point is that distance, this distance from the water. This point right here where your distance is 0, that's not where you emerge from the water. That's where you go into the water. That's where you're going from a positive value to a negative value. You're going from the air, here's the surface of the water, and then you're below water. This point right here is the one you want. We want that x value where the y value is 0. So we can either graph the line y equals 0 or just find the 0 of the function at this point. We want that x value. That is the x value, the time on the stopwatch when we first emerged from the water. So I'm going to do a menu. I'm going to do an analyze graph. There's a couple ways you could do this, but I'm just going to find the 0. Okay, notice down here it's asking me for a lower bound. So that's the point I want. I don't put it on there. I put it on somewhere less than there, something that's less than there. And then click, and now it's asking for an upper bound, and you can see right there, it gave us at 7.8611 seconds, our Y value is 0. Okay, so that is what we want at t equals 7.861. Let's just do 861. Okay, and I'll show you what I'm writing. P first emerges from the water. Okay, and that's all you need to do here. So you had to understand, if they said, tell me the time where P first goes into the water, you wouldn't be finding that 0, you'd be finding this 0 over here. Okay. All right, and just for fun, I know this question doesn't ask this, but what if we needed to solve this thing for x? Get the x by itself. Well, you'd subtract 6 from both sides. Y minus 6 equals 7 cosine of pi over 5 times x minus 2. Divide both sides by 7. 7's cancel. 7 minus 6 over 7 equals cosine of pi over 5, x minus 2. Now we're going to turn cosine of this angle into cosine inverse of this ratio. So cosine inverse of, I'm sorry, that's not a 7 there, that should be a y. I just copied that down wrong from up here. Y minus 6 over 7 equals pi over 5 times x minus 2. Multiply both sides by 5 over pi so that this cancels. We get x minus 2 equals 5 over pi cosine inverse of y minus 6 over 7, and then add 2. So x would equal 2 plus 5 over pi cosine inverse of y minus 6 over 7. Now notice this is a lowercase cosine inverse, which means this thing's a relation, which means this right here is an angle, but there's an infinite number of angles that you could find for this. So if you're finding, let's say you want to find all the places where y equals 0, all the places where on our graph our y value is 0. So that would be this one, that would be this one, and then the next one over here, maybe even this one back here. Okay, you'd have to change the window to see those, but you would be going to the right. There's an infinite number of places where y equals 0. So what you could do here is plug in y equals 0, find cosine inverse of negative 6 over 7. You need your calculator to do that, but you've got an infinite number of answers. You plug in each of those to find your x values, okay? Don't worry about doing that. That's the part that we are not requiring you to do. That's the second part of the questions in 1310 that I told you not to do. All right, thank you all for listening. Have a great day. Finish those problems, and I will see you all soon.